world where X and Y are constantly misunderstood, where lines don't just cross, they collide, like your sleep schedule on a math test. Okay, that was the dumbest thing ever. Okay, forget that. Now, that world is, of course, graphing. And in this video, we're going to be talking about solving systems of equations with graphing, and then later we're going to talk about elimination. Now, say we were to have two lines. The first one is negative 2x plus 6, and the second one is y equals 3x plus 5. These aren't just lines, they're rivals, opposites, like pineapple on pizza and people with good taste. Now, the y equals 3x plus 5 line rises up fast like rent prices, while the negative 2x plus 6 line falls like my GPA in senior year. But where do they meet? Not on Tinder, on the coordinate plane. Did you know that the Latin word for graphing is graphicus maximus linearum, which literally means, dude, draw the dang lines. You see, when the two lines intersect, that point is the solution. It solves both equations. It's like when two people finally agree on where to eat. Well, that seemed pretty easy, right? But these kinds of graph questions usually aren't that easy. Instead of having that nice slope-intercept form, as we did in the last question, rather we would see a type of question like this, 2x plus y equals 10, in which we would need to first convert that equation in a slope-intercept form, and usually graph by hand. So how do we convert this into that beautiful format that we saw earlier? Well, we can do this easily by subtracting 2x from both sides to get y equals 10 minus 2x. And another way to write that would be y equals minus 2x plus 10. And the reason why we write that way is because now we can actually graph really well. Because if you were to look at this coordinate plane right here, we can notice some few things about this graph, and we can actually plot the line based off this little information, this little equation. So we have y equals minus 2x plus 10. Now, this 10 here, that's called the y-intercept. It's the y value of the graph when x is 0. And so we realize that the y-intercept in this case would be 10, right? And then this negative 2, that is the slope, right? We call it m. So if m is minus 2, and remember slope is rise over run, then our rise over run is equal to negative 2. So if our run was like 10, let's say it would be over here, if our x value was 10 then our rise would be minus 20. So then we're able to plot this point here in red, because if you start at this point, this blue point, right, if it runs 10, it would have to rise by negative 20, which, it would actually be falling by 20. With these 2 points now drawn, we are able to graph this line. And if we had some other line, which I won't go into details of how to graph that because we just did it, and it would waste a lot of time for this video. But then if you were to graph that other line, the place where those 2 lines intersect in this very big red dot right here, that is the solution to our systems of equations. Now, I know that I said I would cover elimination in this video, but sadly we're running out of time, so we'll just do that in the next video. But for now, I would like to give a shout out to Miss Bischoff's homeroom. Also, I'd like to give a shout out to Glanville's homeroom and my friends Fatima, Hamna, and Basan.